Welcome back to the deep dive. So, you sent us the StarLink Progress Report 2025, and I have to say what we found in there is it's not just an update on a satellite company. It feels more like a blueprint for a global communications utility.
That's exactly the right way to put it. I mean, 2025 was the year Starlink fundamentally changed its status. It really went from being this sort of high-speed curiosity to, well, essential infrastructure.
Right.
It just accelerated its whole mission to connect the world's most remote and, underserved populations.
So our mission today for you is to break down this massive transformation. We're going to focus on three critical areas. First, the sheer geometric scale of it all, the customers, the commercial side.
Then the technology.
Exactly, the technological engine. The deep resilience and the incredible manufacturing that's required to back it all up.
And finally, the really revolutionary part.
The direct-to-cell service.
Yeah.
Which is just an absolute game changer.
It is. But before we dive into the data, let's just frame the stakes here. The source material makes a point of saying that roughly 1/3 of humanity, we're talking billions of people, they're still offline.
Billions, yeah.
They're relying on slow, intermittent, or just non-existent connectivity. By the end of 2025, Starlink was running across all 7 continents.
All 7.
In over 155 countries. So this expansion is directly targeting that huge global gap.
And the numbers that show this acceleration, they're pretty hard to ignore. After just 5 years of commercial service, they're connecting more than 9 million customers.
9 million?
But the figure that really stood out to me was the speed of it. They added over 4.6 million new active customers in 2025 alone.
Just in 1 year.
In 1 year. That's just surging demand made real.
And what's really fascinating here is that this huge growth, it isn't just rural residential users anymore. The majority of this rapid expansion is coming from commercial sectors.
Sectors that were previously impossible to reach.
Or they were just locked into these incredibly slow, high-cost providers.
Okay, so let's unpack that commercial domination, because this shows Starlink moving from a consumer product straight into essential industrial infrastructure.
Absolutely.
Let's look at aviation. In 2025, the number of commercial aircraft with Starlink nearly quadrupled. It hit more than 1,400 planes.
Wow.
And over the year, we're talking about 21 million airline passengers experiencing consistent Wi-Fi. And not just email Wi-Fi, I mean speeds routinely over 200 megabits per second.
And that dominance, it extends to private flyers, too. In the business aviation world, more than 1,000 business jets are now equipped.
1,000. And what does that mean as a percentage of the market?
Get this, that's over 50% of the active aircraft in that high-end market, the ones they call active tails.
So they essentially cornered half that market in a single year.
They did. It just shows that poor connectivity, even at 40,000 feet, is just... it's unacceptable now.
The maritime sector tells the exact same story.
Yeah, precisely the same. Starlink is now connecting more than 150,000 vessels. That's everything from global cargo ships to fishing fleets to those massive cruise ships.
Over 20 million cruise passengers were served. And I was reading about Royal Caribbean using this huge new infrastructure, this 10 Gbps community gateway they installed.
On their Star of the Seas vessel, yeah. It provides fiber-like speeds for, basically for an entire city floating at sea.
Entire floating city. That brings us to the social utility side of it, where these numbers become truly life-changing. Take U.S. agriculture. The sources note that 60% of American farmers lack adequate internet.
60%.
That's a shocking lack of infrastructure for such a critical industry.
It is. But Starlink is now integrating directly with leaders like John Deere. They co-developed something called JD Link Boost.
Okay, what's that?
It basically incorporates Starlink terminals and modems right into the autonomous machinery. The tractors, the combines.
So real-time data from most remote fields.
Exactly. Huge productivity gains. You see it with crop and coffee farmers in Brazil, too. This connectivity lets them manage everything online, spend more time farming, not, driving around looking for a signal.
It's literally connecting the physical farm to the real-time cloud. And this isn't just about business efficiency. It's about pulling whole communities out of the digital Stone Age.
Right.
We saw hundreds of donated kits installed in about 200 schools across 9 islands in the Bahamas. That's over 40,000 students connected.
And this is all possible because of these innovative community gateway sites. They activated 13 new ones in 2025, so there are 20 total across 9 countries now.
And these gateways, just so you understand, they're like these micro points of presence. They take the satellite signal and turn it into hyperlocal fiber-grade speed.
Up to 10 gigabits per second, it just avoids the immense cost and time of laying traditional fiber.
It solves a major infrastructure paradox.
Absolutely. The first gateway they brought online in the Galapagos Islands is a perfect example.
To protect the marine environment there.
Exactly. It provides high-speed connectivity for residents and researchers, but it avoids the need to lay a subsea fiber cable, which would have been a huge risk to that sensitive environment.
Connectivity without environmental damage. That's a powerful idea.
It really is.
Incredible. So, okay, it's clear the customer base is surging, the infrastructure is being deployed intelligently, but how is the network physically handling that kind of geometric scale? What's the technological engine under the hood?
Well, the engine is immense. It's more than 9,000 active satellites now. But the key technological leap in 2025 was the rapid deployment of the V2 mini-optimized satellites.
Okay, the V2 minis.
They launched over 3,000 of them in a single year. These are 575 kilograms lighter than the older models.
Which means more per launch on a Falcon 9.
Right, and that added over 270 terabits per second of new capacity in 2025 alone.
And here's where the engineering gets really deep, the laser links. Every single satellite has these optical links, and they form this inter-satellite network they call the optical mesh.
Comprised of more than 24,000 laser links.
So why is that number, 24,000, so crucial for you to understand?
Because that number represents the creation of a sovereign, high-speed orbital internet backbone. Think about fiber on Earth. It has to follow roads, go around mountains, cross fragile subsea routes.
Which adds distance and delay.
Exactly. These laser links let the data take a perfectly straight shortcut through the vacuum of space. It completely bypasses all the terrestrial choke points, even national borders.
So the ultimate bottleneck is shifting from the geography of Earth to just the speed of light in a vacuum.
That's it. This lets them route traffic around the world at speeds that are physically impossible on the ground. And we saw this in the real-world performance numbers.
Right.
Users in Asia and Africa specifically saw latency improvements of 30 to 40 milliseconds.
Yeah.
Just because their traffic was routed entirely through space.
That speed sounds great, but is the network truly resilient? I mean, against a real-world catastrophe?
It has proven itself repeatedly. Overall, median peak hour download speeds went up by over 50% in 2025. They're now averaging over 200 megabits per second globally.
And the latency goal is still that 20 millisecond median.
A very ambitious goal, yeah. But the resilience examples are more telling than the averages. When that massive power outage hit Spain and Portugal, the StarLink network stayed fully functional.
Because the laser links just routed traffic around the ground stations that were down.
Precisely.
And we saw the same thing in Nome, Alaska. That community gateway kept critical connectivity going during a months-long subsea fiber break. Weather prevented repairs, but the town stayed online.
Which proves it's not a premium perk, it's an essential utility.
But is that resilience truly scalable? I mean, across the entire globe during simultaneous regional outages? Or are these just, for now, isolated success stories?
The fact that the entire constellation is interconnected by that mesh network means the foundational architecture is designed for global resilience. They're stress testing it every single day. The biggest limiter now isn't the satellite network.
It's the physical scaling on the ground.
It's the sheer physical scaling.
Okay, let's talk about that physical reality, because the manufacturing numbers are just staggering, and they often get overlooked. You can't support 9 million customers by, hand-assembling dishes.
You certainly can't. To keep up with demand, they're ramping up production to an incredible 170,000 kits per week.
170,000.
Across the United States. And this isn't just assembling parts. It requires a kind of vertical integration that most tech companies can only dream of.
The logistical challenge must be immense. What does it actually take to produce that many complex kits every single week?
It takes deep infrastructural investment. For example, their highly specialized PCB factory in Bastrop, Texas, is the heart of the operation. It quadrupled its output in 2025.
And the printed circuit boards, the PCBs, they're the brains of the terminals.
They are. And the quality and speed of that production line directly dictate how many dishes can be shipped. The plan is to double overall StarLink kit production at Bastrop again in 2026. This physical scale is the true differentiator.
It's what separates them from any potential competitor. And they're also focusing heavily on the customer experience, making sure people can diagnose their own problems. I was impressed by the app improvements.
Yeah, they recognize that fast support is critical when your user base is so decentralized. The Starlink app now has a Grok-powered AI chatbot.
Which can actually do things.
It can run hardware diagnostics, it can process replacements, it can even issue service credits, all without a human needing to get involved. It streamlines the whole support chain.
So, okay, we've covered the geometric scale, the infrastructural resilience, the manufacturing power. Now we hit the final and maybe most transformative piece, the direct-to-cell revolution.
DTC, yeah.
This is where they aim to truly eliminate mobile dead zones.
It really raises the ultimate question of connectivity.
Yeah.
How do you connect the unconnectable without forcing the user to buy some new expensive piece of equipment?
And the answer, as of 2025, is the completion of the first-gen DTC network. Over 650 satellites that are basically massive cell towers in space.
And the immediate outcome of that deployment is remarkable. Starlink DTC rapidly became the largest 4G coverage provider on planet Earth,
The largest.
connecting over 12 million people with basic text and data in places where there was zero coverage before.
And crucially, this is all happening through deep commercial partnerships. They've signed agreements with 27 mobile network operators, MNOs, globally.
Right, your typical carriers, the Verizons, T-Mobiles, Vodafones of the world. And these partnerships make DTC available to more than 400 million people who already use those networks.
That collaboration is so key for mass adoption. And their policy on providing free service during disasters, that's also noteworthy. They state they won't profit from misfortune.
And that policy proved to be life-saving during the devastating Los Angeles wildfires. Starlink activated DTC service early, which let over 400,000 people send texts and receive more than 150 wireless emergency alerts.
When the terrestrial systems were failing.
We're just completely overwhelmed, yeah.
The sources gave two fantastic, really human examples of this making a difference. The Girl Scout, who fell into a canyon in Southern California,
Right.
she used DTC to share her location directly with 911. And the driver in New Zealand, whose unmodified cell phone just automatically connected after a remote accident.
She would have been stranded otherwise. It's an incredible demonstration of utility. But the first generation DTC is limited. It's mostly voice and basic messaging. The next chapter requires a huge technological leap forward.
And that leap is tied directly to the fully and rapidly reusable rocket, Starship. This vehicle is the key to deploying the next generation of satellites, the V3s, which are targeting launch in 2026.
The V3 satellites represent a monumental increase in capacity. Each one is designed to deliver over a terabit per second of downlink capacity.
Which is more than 10 times the capacity of the current V2s.
It is, and because Starship is so much larger than a Falcon 9, each launch will add 60 terabits per second of total capacity to the network.
That's more than 20 times the capacity added by a current launch.
20 times.
So what does this exponential increase in satellite capacity translate to for the direct-to-cell service specifically?
It means full 5G cellular coverage. Starlink made a very strategic move in 2025 by acquiring exclusive dedicated spectrum, 50 megahertz of S-band and 15 of AWS spectrum.
So they basically locked down the specific, highly valuable radio channels they need to run full 5G voice and data globally.
They did.
But if they are achieving, 100 times the capacity compared to the first-gen DTC network, does that automatically create interference or conflict with established 5G providers on the ground? Have they really solved that spectrum sharing problem?
They believe they have. It's through specific custom 5G protocols they designed to manage power and handoffs seamlessly. The goal, at the end of the day, is that you will be able to stream movies and make video calls on your regular, unmodified cell phone.
In the middle of nowhere.
In the middle of nowhere. The system is designed to provide a seamless, completely uninterrupted transition between the satellite network and terrestrial networks. You, as the user, will never even notice the switch.
Wow. The total elimination of mobile dead zones globally. I mean, that is the definition of a foundational utility.
If you synthesize everything we've covered, 2025 was the transition year. Starlink went from being a high-speed LEO internet provider to a foundational global communications utility. Essential for commerce, for education, for disaster relief, on land, at sea, and in the air.
That massive scale, though, with over 9,000 active satellites, it does raise questions about the long-term safety of low Earth orbit. What are their specific commitments on that front?
Starlink is very public about its commitment to space safety. They use maneuver decision thresholds for collision avoidance that are actually greater than the industry norm.
And they have these rigorous protocols for when satellites reach the end of their life.
Right. They talk about demisability.
Wait, what exactly does that mean in this context? Are we talking about a planned atmospheric burnup?
Precisely. Demisability means designing the hardware so that it fully burns up upon re-entry. They use a rigorous targeted re-entry protocol over the open ocean, far away from any populated areas. The design of the V2 Mini, for instance, results in an overall risk of human casualty upon re-entry of less than 1 in 100 million.
1 in 100 million. That's incredibly conservative, especially when you compare it to something like the fatality risk in a commercial airplane crash, which is roughly 1 in 11 million.
It is. And this brings us to our final provocative thought for you to consider. When a private company, one that's operating global orbital infrastructure, voluntarily sets safety standards for re-entry and collision avoidance that are far higher than necessary for public safety, what does that imply for how global space infrastructure should be regulated in the future?
Is self-governance by necessity leading the way? And what happens if competitors don't follow that same high standard?
Something to mull over until our next deep dive.